Natural ventilation in a room by ANSYS Fluent. Part 1. Geometry in SolidWorks. First, on the right plane, we sketch a rectangle with dimension 3 by 4 meters. Then using bus extrude, we create the room by extruding it to 6 meters. 3 by 4, and after it, extruding 6 meters. Next, we use the shell command and set a thickness of 10 centimeters to create the walls. Shell for all of the face and 10 centimeters. To create the inlet and outlet opening, we follow these steps. First, we sketch the desired opening on each walls. And after it, using the cut extrude command, we create the holes for airflow. And further sketch and cut extrude. Part 2. Geometry in Design Modeler. In ANSYS Design Modeler, we first import the model, then we create the solution domain. For solution domain, create primitive box, and in box, we use these parameters. For finally a step, using the Boolean subtract command, we subtract the model from the domain. Building and domain, create Boolean subtract target body and tool body. Right. Part 3. Meshing in ANSYS Meshing. First, we define the boundary condition. Inlet as a flow entrance. Send to solver yes, and visible ground as a wall. And extrude for inflation, and outlet as a flow exit. Extrude or exclude. Okay. And finally, select the building surface. Okay. For next step, to generate the appreciate mesh, we use face sizing. Name the opening inlet as outlet, and after name the building for the mesh size. Out opening, and solver no, just for mesh, and visible, no. Building for inflation mesh, yes. Okay, building includes, okay, and also pen includes visible node, sensor node, and create name selection in open. Okay, includes sensor node just for mesh and visible no. Okay, buildings without the open. Building mesh. Okay, sensor no and visible no and exclude complete. Okay, mesh inset sizing, name selection, font open, element size 1 centimeters, resizing for in open 1 centimeters, and finally building mesh, element size 8 centimeters. For the bundle layer, we apply the following setting: mesh, inflation, program control, first layer 1.5 centimeters and layers 5. Okay, next generation. Okay, after completing the mesh generation, the quality is checked using the skewness parameter. The value of less than 0.85 is considered acceptable. We're sitting in ANSYS Fluent. First, we check the scale mesh of the model. Next, we apply the solver setting. Okay, in meters. Okay, close. The setup means energy on for air, constant, create, the zone condition, pressure in operation condition, okay, and for inlet, get 5, okay. For the convergence, before the convergence methods, impel and second order and control under relaxation factor, pressure 0.3 and turbulence and specific. Okay. Okay, for the convergence, restoration is monitored as a point near the building. Report definition, edit, new, surface report, a rated average, variable velocity, and new point, end point, and 3 rate, and point, and after residual, and okay. Initializing for compute from inlets. And for run calculation, report interval and Number of iteration 15,000. Not good. Result section. In contour panel, we can plot the velocity and pressure contours like this. But in the CFD-Post, we can also visualize the streamline or vector to better understand the flow behavior. So, create a plane, X, Z plane, 1 meters, and the vector in plane 1, symbol 0.1. Okay. Vector, and let's opening and flow out. On the contour. Plane 1, local velocity.